Hello everyone and welcome to today's lesson on triangles. The Pythagorean theorem is a really high-yield equation which states that the length of the hypotenuse, or c squared, equals the sum of both of the lengths of the sides of the triangle squared, or a squared and b squared. C will always refer to the hypotenuse, which is the longest side. A and b can refer to either side of the triangle. For the sake of this triangle, let's call this side A and this side B. Let's check now if the Pythagorean theorem is true for this triangle. We can write 3 squared plus 4 squared equals 5 squared. Simplifying both sides of the equation, we can see both sides equal each other, which means it is true for this triangle. Try practicing the Pythagorean theorem now with this triangle and see if you can get both sides of the equation to equal each other. Let's talk now about sine, cosine, and tangent. You may already know the equations you need to use to calculate these because of this mnemonic SOHCAHTOA. Before I explain these equations more, I want to talk about what all of these terms actually mean. Looking at this triangle, we can see that the longest side is this side here, which I'll label now as the hypotenuse. One easy way to tell where the hypotenuse is on a right triangle is to find the right angle and then look at the side opposite of that. Because the right angle is here, we know the line on the other side of it is the hypotenuse. If I were to draw more triangles here, we can see that the hypotenuse is always on the opposite side of the right angle. So hypotenuse is a specific and objective term. These other terms, opposite and adjacent, are not objective. They're relative to our angle of interest. For instance, if I pick this angle as the angle of interest, it would mean that my opposite side is the side opposite of this angle, which would be this side, which I'll label as O. The side touching this angle is the adjacent side, which I'll label with A. Again, these are relative. If I chose to label this side as theta instead, then it would make this side the adjacent side because it's touching the angle, and the side on the other side of the triangle the opposite side. Here's a table of the sine and cosine values you should know for the MCAT. The highest yield values to know here are the values equaling 0, 0.7, and 1. I've arranged the values like this in this table to show you two important things. The first is that the sine value increases as you increase the angle from 0 to 90 degrees. We can see the sine of 0 degrees is 0 and the sine of 90 degrees is 1. The opposite of this is true for cosine. The cosine of 90 degrees is 0 and the cosine of 0 degrees is 1. So, between 0 degrees and 90 degrees, sine and cosine have an opposite pattern. I have also included this column here to show you that there's a pattern to calculating these numbers. Notice we go from the square root of 0 to 1, 2, 3, then 4. Of course, you could rewrite these numbers as 0, 1 over 2, and 2 over 2, but I wanted to show you that this pattern exists as a teaching point. Let's put this all together now with a practice triangle. I want to calculate the cosine of this angle. Now, we already know all of the lengths of this triangle, so we won't be solving for any variables, but I want to do this to give you an idea as to how the math all works. Assuming we know that theta here equals 60 degrees, we can set up our equation. Cosine of 60 equals the adjacent over the hypotenuse. The blue side here is the adjacent side because it's the short side of the triangle that is touching the angle. The hypotenuse is the green side because it's the longest side of the triangle and it's opposite to the right angle too. Setting this all up, we can see the cosine of 60 degrees equals 10 over 20. Pulling from our table, the cosine of 60 degrees is half, or 1 over 2. Simplifying both sides of the equation, we can see 1 over 2 equals 1 over 2, which means all of the math we did here was correct. Let's use these equations to solve for a value that we don't know. Let's choose this angle, again I'll call it theta. We know theta here equals 45 degrees. Now, this time I want to solve it using sine, so I'll put sine of 45 degrees here equals the length of the opposite side, 5, over the length of the hypotenuse, which I'll call h since we don't know it. Now, before we try solving this, I want to rearrange the equation to get h isolated, so let's do that now. I'm going to multiply the h over and divide the sine 45 degrees over at the same time so they both swap places. Now, pulling from our table here, we can replace the sine of 45 degrees with the square root of 2 over 2, giving us the equation h equals 5 over the square root of 2 over 2. Using algebra to simplify this down, we get our final answer of 5 times the square root of 2. And this is the right answer. Check for yourself with a calculator. If you have any questions, feel free to leave them in the comments. Don't forget to like and subscribe, and that concludes our lesson on triangles.